A spacecraft is launched on a mission that looks simple at first. Push it harder, push it faster, push it closer to the speed of light. Inside the cabin, nothing seems unusual. The instruments glow steadily. The crew breathes normally. Their hands do not feel any different. Their voices remain calm. But outside the ship, something begins to happen that should not be possible in everyday life. The stars begin to shift in strange ways. Distances stop behaving like fixed numbers. Light itself starts to bend around the motion of the spacecraft. And slowly, reality stops matching what human intuition expects. The deeper the spacecraft goes into extreme speed, the more the universe begins to separate into two versions. One version belongs to the travelers. The other belongs to everything left behind. This is not science fiction. This comes directly from one of the most tested ideas in modern physics. Einstein's theory of special relativity describes what happens when objects move close to the speed of light. And according to this theory, the universe has a built-in rule that no object with mass can ever reach or exceed the speed of light, not because of engineering limits, not because of fuel limits, but because of the structure of reality itself. The speed of light is not just a number, it is a boundary, a hard limit written into space and time. At ordinary speeds, this limit does not matter. Cars, planes, and rockets move so slowly compared to light that physics feels normal. Time flows evenly, space feels stable, cause and effect remain predictable. But as speed increases closer and closer to this limit, the rules begin to change in ways that feel almost disturbing. Time no longer behaves as a universal constant. Space no longer remains fixed. Even the idea of now starts to lose meaning across different points in motion. The closer a spacecraft moves to light speed, the more the universe reshapes itself around that motion. It is not the ship that breaks first. It is reality itself that begins to distort. Most people assume speed only affects movement. Faster means you arrive sooner. But in relativity, speed affects something far deeper. It affects time itself. Clocks do not tick at the same rate for everyone. Two observers moving differently can experience time at completely different speeds. One may age normally. The other may drift through years while barely aging at all. This is not speculation. This has been confirmed through experiments with atomic clocks and fast-moving particles. Even tiny increases in speed produce measurable changes in time, but when a spacecraft approaches a significant fraction of the speed of light, these effects stop being small. They become extreme. Time begins to stretch, compress, and separate between inside and outside observers. At the same time, space itself begins to change. Distances in the direction of motion shrink for the travelers. What looks like a vast interstellar gap from Earth becomes dramatically smaller on board the spacecraft. The universe does not disappear. It bends. It folds in on itself along the direction of motion. This effect is called length contraction, and it becomes stronger as speed increases. But here is where things become truly disturbing. These effects are not just physical curiosities. They lead to a breakdown in shared reality. The crew inside the spacecraft and observers outside the spacecraft do not agree on what is happening. They do not agree on how much time has passed. They do not agree on how far the journey has been. In some sense, they are living in different versions of the same universe. And this leads to the central question that drives everything forward. Why does motion affect time at all? Why should speed change something as fundamental as the flow of moments? Why should moving through space alter the structure of time itself? As the spacecraft moves closer to light speed, these questions stop being abstract. They become physical. They become unavoidable. And the answer to them reveals one of the most unsettling truths in all of physics. The universe is not built on separate layers of space and time. It is woven together into a single structure that bends when you move through it. In this video, the journey begins at ordinary speed and ends at the edge of light itself. Step by step, we will uncover what happens to a spacecraft as it approaches this ultimate limit. And what it reveals is not just about space travel. It is about the nature of reality itself and how fragile our everyday understanding of time truly is. Stay with this until the end, because once the full picture becomes clear, the idea of traveling to the stars will never feel the same again. Welcome to the channel. If you enjoy exploring the deepest ideas in physics and space, subscribe, because what comes next will challenge everything you think you know about the universe. The idea of pushing a spacecraft closer and closer to the speed of light sounds simple. First, just keep adding energy, just keep accelerating, but physics does not allow a smooth path into that regime. The closer an object with mass gets to the speed of light, the more the universe resists the motion itself. At everyday speeds, adding speed is easy to understand. A stronger engine gives more acceleration. A longer burn gives more velocity. The relationship feels linear, but as the spacecraft begins to approach a significant fraction of the speed of light, that simple relationship breaks down. Each additional increase in speed requires more energy than the one before it. Not slightly more, dramatically more. This is one of the least intuitive parts of modern physics. The mass of the spacecraft does not literally increase in a classical sense, but its resistance to acceleration grows in a way that behaves as if it becomes heavier. The result is that the ship becomes harder and harder to push forward. At very high speeds, even massive amounts of energy produce only tiny changes in velocity. There is a point where the effort becomes extreme. To move from 90% of light speed to 99% of light speed is not a small step. It requires an enormous increase in energy, and moving even closer becomes exponentially harder. Each decimal placed toward light speed demands more power than the entire previous journey combined. This is not an engineering problem. It is not about fuel efficiency or propulsion design. It is built into the structure of space and time itself. The equations of special relativity show that as speed increases, time and space begin to adjust in a way that protects the speed of light as a limit. The universe does not allow objects with mass to simply cross that boundary. Light itself behaves differently. It has no rest mass. That is why it can move at this ultimate speed without restriction. Everything else, from atoms to spacecraft, carries mass. And that mass becomes the reason why light speed remains unreachable. As the spacecraft gets closer to this limit, the energy required to continue accelerating starts to grow without a normal ceiling. It does not just increase. It explodes upward in a mathematical sense. This is why no known particle accelerator, no matter how powerful, can push matter to the speed of light. There is another lesser-known detail that makes this even more extreme. At these speeds, even tiny particles in empty space become dangerous. A single hydrogen atom, normally harmless, carries enormous energy when hit at near light speed. The spacecraft is not just fighting against acceleration limits, it is moving into a region where the environment itself becomes hostile. The closer the ship gets, the more it feels like pushing against an invisible wall. Not a physical barrier in space, but a limit embedded into reality. Every attempt to go faster requires more energy than the entire previous effort. And yet the speed of light remains just out of reach, always ahead, never. Even the concept of almost there begins to lose meaning. Because in physics, there is no true arrival at that boundary for anything with mass. Only endless approach. At first, time feels completely normal inside the spacecraft. The crew follows their routines. Clocks tick at a steady rhythm. Conversations flow naturally. There is no warning sign that anything strange is happening. Nothing inside the ship tells them that they are leaving the normal rules of time behind. But outside the spacecraft, the universe is no longer matching that steady rhythm. As speed increases closer to the speed of light, time begins to stretch, not in a metaphorical sense, but in a physical one. Clocks outside the spacecraft begin to tick faster compared to the clocks on board. From the perspective of Earth, the crew is moving through time more slowly. This effect is called time dilation. It is one of the most surprising predictions of Einstein's relativity. And it is not theoretical, it has been measured. Even extremely fast particles created in laboratories live longer than they should because their internal clocks slow down at high speeds. Inside the spacecraft, nothing feels different. A second is still a second. A heartbeat still feels normal. But compared to Earth, those seconds begin to stretch. The faster the spacecraft moves, the stronger this effect becomes. At everyday speeds, it is too small to notice. But near the speed of light, it becomes extreme. There is a mathematical factor behind this called the Lorentz factor. It describes how much time slows down as speed increases. At low speeds, the factor is almost 1, meaning no visible change. But as speed approaches the cosmic limit, the factor grows rapidly. Time inside the spacecraft slows dramatically compared to everything outside. This is where things become unsettling. If the spacecraft travels for what feels like a few years to the crew, decades, centuries, or even longer may pass on Earth, the ship is not just moving through space, it is moving through time at a different rate. One lesser known detail is how sharply this effect begins to rise. It does not increase in a straight line. It curves sharply upward as speed gets closer to light speed. This means small increases in velocity near the limit produce huge differences in time experienced. A tiny change in speed can separate years of Earth time from months of ship time. For the astronauts, aging slows down compared to people left behind. Their bodies continue to function normally, but the outside universe advances faster. Stars evolve, civilizations change. Entire histories can unfold while the crew experiences only a short passage of time. There is no way for the crew to feel this difference directly. No internal signal warns them. Only comparison with the outside universe reveals the truth. And that comparison is not available until communication or return becomes possible. This leads to a strange one-way structure of travel. The spacecraft does not just move forward in space. It moves forward in time relative to Earth. When it finally slows down or returns, the difference becomes visible. The universe outside has aged far more than the people inside expected. Time does not behave like a shared constant anymore. It splits into separate paths depending on motion. As the spacecraft continues to accelerate, another strange effect begins to appear. It is not just time that changes. Space itself begins to behave differently. Distances stop being fixed and absolute. They begin to depend on motion. From Earth, the journey still looks enormous. Stars remain separated by vast gaps. Entire light years stretch between destinations. Nothing about the universe appears to shrink or compress. Everything seems stable, wide, and permanent. But inside the spacecraft, the situation is very different. As speed increases closer to the speed of light, distances in the direction of motion begin to shrink, not visually like a zoom effect, not like an optical illusion. The space itself contracts. This is known as length contraction. It only happens along the direction of travel. Sideways dimensions remain unchanged, but forward distances, the ones that matter for interstellar travel, become shorter. The faster the spacecraft moves, the more extreme this contraction becomes. There is a lesser known detail that makes this even more unsettling. This contraction is not something the spacecraft detects with instruments. It is built into how space is measured from the perspective of motion. Different observers do not just disagree on time, they disagree on distance itself. From Earth, a destination might be thousands of years away at sublight speeds. The idea of reaching another star system feels almost impossible within a human lifetime. Even the nearest stars seem out of reach for normal travel. But inside the spacecraft moving near light speed, that same distance becomes dramatically smaller. The ship does not feel like it is. crossing an impossible gap. The universe appears compressed along the path forward. The destination feels closer than it should be according to Earth-based measurements. This creates a strange split in reality. Both viewpoints are correct. Earth measures the full distance. The spacecraft measures a shortened distance. There is no contradiction in physics. There are just different frames of reference describing the same universe. As speed increases even more, this effect becomes stronger. At extreme relativistic speeds, distances can shrink so much that interstellar travel begins to look almost manageable from the perspective of the crew. Not because space has changed physically in a universal sense, but because motion reshapes how space is measured. One surprising consequence is that the spacecraft is not actually traveling through a fixed amount of space in the way people usually think. Instead, space and time are intertwined. Changing one changes the other. High-speed warps both. Together, this leads to a deeply unsettling realization. The universe does not agree on a single, shared version of distance. There is no universal map where every observer sees the same layout. Instead, space depends on how fast you move through it. From one viewpoint, the journey is impossible. From another, it is shortened, and neither view is more correct than the other. As the spacecraft pushes closer to light speed, another hidden danger begins to grow. It is not only time that slows or space that shrinks. Energy itself reaches levels that stop feeling familiar. Motion at these speeds is not gentle. It is violent in a physical sense. The kinetic energy of the spacecraft increases without a simple limit. At normal speeds, energy grows in a predictable way. But near light speed, the increase becomes extreme. Each small gain in velocity requires a massive jump in energy. The ship is not just moving faster. It is carrying enormous stored energy in its motion alone. This energy does not stay harmless. It becomes dangerous in interaction with the universe around it. Space is not empty. It contains particles, atoms, and radiation scattered across vast distances. At everyday speeds, these are harmless. A hydrogen atom drifting in space is insignificant. But at near light speed, that same hydrogen atom becomes a high-energy projectile. From the perspective of the spacecraft, even a single particle impact carries the force of a powerful explosion. The faster the ship travels, the more severe each collision becomes. Space begins to feel less like empty vacuum and more like a storm of invisible bullets. There is a lesser-known effect that makes this even more intense. Cosmic background radiation, which normally fills space at extremely low energy levels, shifts in frequency due to the spacecraft's motion. In front of the ship, this radiation becomes compressed and blue-shifted. It gains energy. It moves into higher and more dangerous ranges. This means the spacecraft is not just moving through empty space, it is moving into a concentrated field of high-energy radiation from its own motion. The front of the ship effectively becomes exposed to intensified energy from every direction of travel. The result is a constant bombardment. Particles strike the spacecraft continuously. Radiation increases in intensity. Even regions of space that seem calm become hazardous at these speeds. The environment itself turns hostile without changing its actual contents. Engineering a shield for this becomes almost impossible. At lower speeds, shielding is straightforward. Materials absorb or deflect incoming particles. But at relativistic speeds, the energy of impacts grows beyond normal material limits. No known structure can withstand repeated collisions of that magnitude for long periods. There is also a subtle problem that is often overlooked. The energy is not only external, the spacecraft's own motion stores enormous internal energy. If that energy were released, suddenly it would be catastrophic. The ship becomes a tightly contained system holding extreme energy under constant stress. Even small imperfections in shielding or structure become critical. A single weak point can lead to cascading failure. The difference between safe travel and destruction becomes razor thin. At this level of speed, space is no longer a calm environment. It becomes a high-energy field that interacts violently with anything trying to move through it. The spacecraft is no longer just traveling through the universe. It is forcing its way through a medium that responds with constant force. As the spacecraft moves deeper into near light speed travel, another problem begins to appear. It starts quietly at first. Messages from Earth still arrive. The signals still carry voices, instructions, and updates. But something about them feels slightly off. The delay begins to grow. At low speeds, communication is almost instant. At higher speeds, a small lag appears. But as the spacecraft approaches relativistic velocity, that delay expands dramatically. Messages from Earth take longer and longer to arrive. Conversations stop feeling like conversations. They become separate events. A simple question sent from Earth might take hours to reach the ship. The reply might take even longer to return. By the time an answer comes back, the situation on Earth may have already changed completely. Communication becomes fragmented, not broken, but stretched across time. There is a lesser-known detail that makes this even more complex. The distortion is not only about delay, it also affects how signals are interpreted. Frequency shifts caused by high-speed motion can stretch or compress signals. Voices can become altered. Timing between words can shift slightly, changing meaning in subtle ways. But the deeper problem is not technical. It is fundamental. It comes from something called relativity of simultaneity. In simple terms, different observers do not agree on what. Events happen at the same time. There is no universal now that applies everywhere in the universe. From Earth's point of view, certain events are happening at this moment. From the spacecraft's point of view, those same events may not yet have happened or may already be in the past. Both perspectives are correct within their own frames of reference. This creates a strange breakdown in shared reality. The crew and Earth are no longer operating in the same timeline. They are not just separated by distance. They are separated by how time itself is ordered. As speed increases, this difference becomes more extreme. The concept of coordinated time starts to fall apart. Earth-based schedules, plans, and expectations lose meaning for the crew. The same applies in reverse. Earth cannot accurately track the present state of the spacecraft without delay and distortion. There is an important consequence that is often overlooked. Even defining what is happening now becomes impossible across both frames. Each side has its own version of reality that cannot be perfectly aligned with the other. For the crew, Earth begins to feel like a place frozen in delayed snapshots. For Earth, the spacecraft becomes a moving object that is always slightly out of sync with present time. Neither side is wrong, but neither side shares the same present moment. As communication stretches and time coordination collapses, a subtle isolation grows. The crew is still connected to Earth, but that connection no longer operates in real time. Messages arrive like echoes from a different version of reality, slowly separating both worlds. Inside the spacecraft, everything still feels normal to the crew. The walls are steady. The instruments behave as expected. Daily routines continue without interruption. Sleep, work, and conversation follow familiar patterns. There is no internal signal that anything extraordinary is happening. Time, from their perspective, moves in a straight and predictable line. One day follows another. Nothing feels stretched or compressed. The human mind inside the ship cannot directly sense the effects of near light speed travel. All biological processes continue at their own steady rhythm. But outside the spacecraft, the universe is not waiting. It is changing at full speed. Galaxies rotate and reshape over vast timescales. Stars are born and die. Solar systems evolve. Entire civilizations, if they exist elsewhere, could rise and disappear in what feels like moments to cosmic history. There is a lesser-known consequence of this difference. The crew is not just separated from Earth by distance. They are separated by time that is passing at a completely different rate. For every year experienced inside the spacecraft, many more years may pass outside. The universe outside ages faster while the crew remains comparatively unchanged. This leads to a disturbing imbalance. The longer the journey continues, the greater the gap becomes between the ship and everything it left behind. Earth does not remain paused. It continues to evolve, even if no signals arrive in real time. Cities change. Languages shift. Generations are replaced. At some point, the idea of returning becomes something else entirely. It is no longer a simple homecoming. It becomes a jump into a future that cannot be predicted. The crew may return expecting familiar faces and familiar places. Instead, they may find a world that has moved on without them. This creates a psychological weight that builds slowly. The crew does not feel time distortion directly, but they understand it intellectually. They know that every moment inside the ship is not equal to a moment outside. That knowledge grows heavier over time. There is also a subtle emotional isolation that forms. Communication delays already weaken connection with Earth. But now there is a deeper separation. Even shared history begins to diverge. The crew remembers one version of events. Earth continues creating another. The journey begins to feel less like travel through space and more like drifting through time without control. There is no way to stop the progression, no way to return to the exact moment left behind. Every second moves them further into a future that has already started forming outside the ship. The most unsettling realization is this: the spacecraft is not simply moving across the galaxy. It is moving forward through time at a different rate than everything else. The destination is not just a place in space. It is a version of reality that no longer matches the one they came from. Near light speed travel is not just about moving faster. It is not just about reaching distant stars in less time. It is something far deeper. It changes the way reality itself behaves. Time stops being the same for everyone. Space stops being fixed and absolute. Energy rises to extreme levels, even because an effect begins to separate depending on the observer. What looks simple from one frame of reference becomes completely different from another. The spacecraft does not break the laws of physics. Instead, it moves into a region where those laws reveal their deeper structure. Relativity does not allow shortcuts. It does not allow free passage through space without consequence. Every step closer to light speed reshapes how the universe is experienced. There is no rule that forbids this kind of travel in theory. The equations allow it, but the same equations also reveal the cost: time separation, energy extremes, communication loss, distance distortion, and a growing gap between what the travelers experience and what the rest of the universe continues to become. The universe does not stop anyone from trying, but it does not make the journey gentle either. Every attempt to approach light speed brings consequences that build quietly at first, then become impossible to ignore. The closer the limit, the stranger reality becomes. In the end, the most unsettling idea is not the speed itself. It is what that speed does to connection, to history, to shared experience. A crew traveling at near light speed is not just moving to another place. They are moving into another version of time. And when they return, nothing guarantees that the world they knew will still be there in any meaningful way. People may be gone. Civilizations may have changed. Even the idea of home may no longer match memory. Reaching the stars may not be about distance alone. It may be about leaving everything familiar behind, not because of distance in space, but because of distance in time that cannot be avoided. If you found this journey into the limits of reality interesting, like the video and subscribe to the channel. There is much more to uncover about the universe, and the deeper we go, the stranger it becomes.